Okay, I am here. I'm about to hit broadcast. Let's let everyone in. Hello, everyone. Welcome. Oh, people are now coming in. We've got a few minutes to go before we start off, but I'd like to see who's here. So feel free to say hi in the chat. Where are you from? Who are you? Do I know you? Do I not know you? Are you new? All that other good stuff. And in a few minutes, we'll start up. I love seeing the numbers go up and up and up as people sort of join. Hello. Hey, Pedro. Especially hello. Oh, Portugal. Fantastic. You know, it's nice at a time when people aren't traveling that I can see people from all the places that I visited or wanted to visit. Ah, from Pittsburgh. Yes. Well, I was supposed to be there in about 2 weeks for PyCon, but strangely, PyCon was canceled this year. Don't know why. Oh, yeah, really high. So, yeah, it's really actually disappointing on a whole lot of levels. So they basically said that we'll give our talks. I have a talk. I was going to have a booth. I had all these T-shirts I was going to be printing up, and instead I'll be giving my talk online. It would seem. Oh, someone's raising their hand. You can just like chat or talk or whatever. Yeah, the world is now closed. Exactly. I don't even know what to do when someone raises their hand. I don't know. You can just like talk, I guess. I'm not sure how this works. Hopefully people can just like people can just use the chat. There's a chat on the side there. If you found the hand raising thing, I've actually never seen that, but maybe it's because I'm like in charge. I don't know. These are 2-3 minutes. Give people a chance to show up, and then I will gladly start things up. We have now something like 900 people registered for this course. How many are actually going to come? How many actually? Oh, so we have the hand at the top. Okay, good. So how many actually show up to the webinar? In the past, it was like 100 people or so, but hopefully that'll go up. And of course, the recordings are available. So if people can't make it for whatever reasons, and this is a kind of convenient time, I think, for people in Europe and the US. It's pretty inconvenient time for people in Israel. And it's like ridiculously inconvenient for people in like India, not to mention China and so forth. But, you know, there's a limit as to how many time zones I can actually handle at the same time, I'm afraid. So we'll just have to sort of hope for the best on that front. Oh, hey, Larry, Boston, yes. Oh, yeah, someone's in Australia. I see. So, wow. So you're either, what time is it in Australia? It's like ridiculously late, no? So I'm either honored or you should find a better hobby. All right, excellent. Yeah. I'm very happy to provide the recordings and everything, and hopefully they're good and useful and so forth. Ireland. Well, I was hoping to go to Ireland this year in July for EuroPython, but no. Someone asked if there is a webinar having an upper limit. So the answer is yes and no, my favorite answer to all questions. So I've had a Zoom account for like 3-4 years now for doing online training and meetings and so forth. And then the whole world discovered Zoom like a month or two ago. And so I just saw the CEO said they went from having 1 million people use it to 20 million people use it simultaneously. Heaven help them on their scalability. So the original plan that I had was good for up to 100 people. And I decided to actually purchase the webinar plan just in case, which is good for up to 500 people. And so hopefully, I'd be delighted if we had that many people. I just want to make sure that if we got to like 101, the person would not be locked out. I also think there's slightly different functionality on the webinar front and the meeting front. I don't know exactly what that is. And the documentation leaves something to be desired. So there you go. Okay, excellent. Oh, I'm glad you're able to join. All right. Oh, chat is set to all panelists. Oh, do I have to like set something to allow people to chat? Allow attendees. So allow attendees to chat with all panelists and attendees. So I have that set actually. So, Ian from Pakistan asks, are we going to be teaching advanced Python libraries or just basic stuff? So this course is specifically designed for people without programming background and is very introductory in its nature. I have paid courses that are for people who want either like introduction for people who have programming experience and also advanced level courses. I sometimes do free webinars as well. I have my newsletter, which is free, which goes from very basic to very advanced, sort of depending on my whims in the week. But this specific course is about sort of the basics of core Python. That said, I would be surprised if people who have some Python experience and programming experience will get something out of it. I mean, that's certainly my hope. I hope that'll be the case. So here's the plan for today. I want to go over the homework questions that I put in the forum. I know that a bunch of people asked for me to check over things. I tried to do that. If I don't get to it, I'm sorry. This week I actually had to like turn in the last chapter, or I should say the first chapter, the preface of my book with Manning. They were beginning to get a little impatient with me. So I actually turned that in. It's a draft, but now I have some more time until it comes back for final proofing and so forth. So I'm going to try to go through the forum and answer a whole bunch of questions, whatever people have. And if I don't get to you, you can just sort of like shout out to me. Don't forget to put like @Reuven, and that makes it more likely that I'll see it, and I will try to attend to that more quickly than otherwise. Oh yeah, so if people want to see the GitHub, so let me just grab that. Okay, so if you go to, I'm just going to copy this into the chat here. If you want to see a almost real-time version of the Jupyter Notebook that I'm working on now in the course. I mean, right now it's empty, but you can go there. That's the GitHub. That's the GitHub repository, or the Git repository on GitHub for this course. You can also just like view it or clone it or view it afterwards. But the really cool combination of Git auto push and GitHub allows you to see it in almost real time. I say almost because it's like about 2-minute delay. Oh, I see there are questions. Let me see if I can see like open. Chat is set to all panelists. Oh, hopefully that's now set. Hopefully people are now able to set things. Here, all the panelists and attendees. I see some people have been setting that. You have to actually change. There's a little menu there. You have to change who you want to set it to. I made that mistake the first week myself, so I apologize for that. Okay, so the plan for today is I want to go over the homework questions I put in the forum. The second thing is then we're going to go, well, if there are any questions, obviously, I'm happy to answer those. And we're going to spend time today talking about numbers. And in talking about numbers, we'll also talk about all sorts of other stuff as well. So let me grab, let's see. The chat setting is for each attendee, not just the host. Oh, link is broken. That's weird. Let me go to it now. 404 error. Egad. Seems working okay for me. Maybe it's like, all right, hold on a second. Maybe I need to put like a private, maybe I somehow made this a private repository. I'll just try like going to an anonymous window, see if that helps. Oh my goodness, yes. How is that possible? That is super weird. Okay, hold on. I'm going to make this public now. Because like people always love to hear. It works fine for me. So let's see. It is currently make it possible. Oh, what do you know? Oh goodness. Oh, you know what happened? I think maybe no. I think I just made a mistake. Oh, and I'm gonna do that. Come on. Thank you very much for letting me know. And no, it's not GitHub's issues. This is a me issue, I'm afraid. All right, so now I'm going to try this again in a private window, and let's see if that will work. All right, that definitely won't work. Yeah, and now that's working fine. Okay, you should be able to go there now, and you should have access to it, and I'm sorry about that. Yeah. Okay, phew. All right. So let's talk about the homework. So last time we talked about a few different things, but the main thing we talked about was the if statement. And that's how we make decisions in any programming language, but especially in Python. And what we're basically doing is saying, if something is true, then do blah, 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 blah. Otherwise, do blah, blah, blah. And so you have to choose between true and false. So let me go and do some sharing here. Let's see. Good. Share screen. Wait, where did my, hold on a second. I just had my, did I get rid of, hold on a second. That's funny. All right, and then I guess, okay, hold on. We'll get this working in a moment. Come on. All right, now it's not even like letting me share. Okay, there we go. And now I'm gonna do that. And I'm gonna go here. There we go. Come on. It's running somewhere. I don't know where that window went. I guess I killed it off or something in trying to figure stuff out. Oh, for crying out loud. Why is it now taking so long? Technology, folks. Yes. All right. Let me kill this off. Let me just go here in this window and hope this works. So let me go now and just pull up the questions I gave you. And by the way, like just to understand how this homework works, in my opinion, I'm going to post some questions. You don't have to, absolutely have to do anything with them. You can look at them. You can answer them in the forum. That's great. If you do, then I or others can give you some feedback. It's a great way to sort of just better understand what's going on. Oh, wait, there's more here. What is more supposed to be in chat? Oh, yes, the chat was closed. Haha. Demo IDs, yes. So I'll tell you actually, like I do live coding every day, like professionally, and I do not understand why this is like giving me trouble right now, of course. Let's try this. Let's even, hold on, I'm gonna try something else as well. All right, this is of course, oh, no, this is super weird. All right, maybe I'll just like start a new one, and that's that. All right. All right, if not, I'll just like kill off Jupyter and start it again. That's also a legitimate option here, I'd say. Kill off other things on my computer. Wow, I've never had things go quite this bad, quite this quickly. All right, I am actually going to kill off Jupyter now and just restart it. That seems to be like the easiest way to go here. And I don't know what else is going wrong. Let's get rid of that. Well, everything is like, whoa. Right. Sorry. Kill that off. Very good. Something's like, whoa, something's using a ton of CPU on my computer. What is it? Maybe it's Zoom, actually, for all I know. All right. Holy cow. All right, so let's see if I can get Jupyter work. And if this causes problems in the future, then I will like set up a virtual machine somewhere so it doesn't have to load up my computer too much. All right. Oh, and of course now that's working just great. Yeah. All right. Okay, I see like on the server side here, it's like starting to do the right thing. It's thinking, it's thinking. It's thinking a lot. Wow, this is really weird. All right, and a little embarrassing, I'm sorry. Okay, so maybe, oh, wait, here. It's thinking, there we go, almost there. Ta-da, see, Python is so easy to work with and use. Okay, so the questions we had from last time, there we are. That at least worked. Copy and paste is working fantastically today. All right, so as you enter two words, which we can put into two variables, first and second. And then we're going to use the less than and greater than operators on the words to print like whether whether they're the same or one comes earlier or later. So before we do this, whenever you have like a task, and this too in general programming, not just like for assignments as it is, you want to sort of play with this idea a little bit. And you want to understand that whenever we have if, whatever I have if, it's like true or false. That's the only option that you can give if, true or false, and then do something. And then else, right, do the opposite. That's basically what's happening there. Okay, so if that's the way it works, then we have to figure out how we're going to get a true, how we're going to get a false. And you want to do a little experiment. And so here's how I'm going to experiment. I'm going to say, hey, is A less than B? And the answer is true. So at least in the Python world, less than and greater than don't only work on numbers, they also work on words. So I say, is A less than B? Is B less than A? No, that's false. How about is A less than A? No. Is A less than or equal to A? Well, yes, that's true. So basically, in each of these cases, the tests that we're running return a true or a false value. And so I can put any of these, A is less than B, B is less than A, I can put any of these in an if statement. And because we're getting a true or false value back, then Python will be like, you're getting a true value, I'm going to do this. You're giving me a false value, I'm going to do the else thing. But we also saw last week that there's a third part of this. That's elif. So I can say if true or false, do something. Now I can say elif, true or false, do something else. That's sort of like the way I would describe it. And so elif gives you another shot. It says, oh, if was not true, but maybe there's something else that is true. All right, so you could really like do this sort of thing here with if one's true, oh no, what if the other's true? Oh no, well, in all other cases. So what I'm going to do is I'm going to say something like this. I'm going to say, and this is what we call pseudocode. This is like taking the specifications and turning them into something that sort of kind of looks like code, but isn't really code. So I'm going to say, first of all, I'm going to get the words. Well, I'm going to say if first comes before second, then we're going to print first comes first alphabetically. And I can say else, or elif, first comes after second. Then we'll say here print second comes first alphabetically. And in all other cases, we say else, print, the two words are identical. Right? These are the three possibilities that we can deal with. So how can I translate this condition, if first comes before second, into code? Well, I can say if first is less than second. Wait a second, what is this first, what's the second? I did define them. Oh yeah, that would be pretty useful, huh? First equals input, enter first word. Then we'd say second equals input, enter second word. So first less than second, that means if it comes first alphabetically, then neat, great. If first comes after second, well, let's just say then second is less than first. Then we say, well, second comes first alphabetically. And then we can say, otherwise the two words are identical. And so this is like, there are no other options. There are basically no other options here. Less than, greater than, or equals. You can play with them in different ways, but that's basically what it comes down to. And because of the way that Python compares strings, because of the way Python compares text, this actually works just fine. So I can now, let's run this. I'm going to say here, apple and banana. And it says, oh, wouldn't it be nice to say instead of just first and second, the actual words? So here I'm going to use an F string. An F string lets me replace with curly braces inside the string. And I can say here, second comes first alphabetic. Or we can even say first comes before second. And we say second comes before first. And then we say first and second are identical. Let's make that F string there as well. So now if I say apple and banana, then it'll say apple comes before banana alphabetically. This is true. And if I say here, banana and mango, banana comes before mango. If I say here, mango and, I don't know, zebra, a well-known fruit, right? So you can see how we can do this in either order. I don't know, did I do it in either order there? Let's just do this again so we can show the either order, right? Zebra and mango, right? So, and it's doing a great job. And what if I say here, elephant and elephant? Elephant and elephant are identical. All right, so this is how we can use the if statement to check for things, test for things. And the key is what we're getting here, the value we're getting back must be true or false. There's no way around it. And if you don't give Python a true or false value, it will force the value to be true or false. It'll go to the value and say, listen, I know you're an integer, but which are you closer to, true or false? And it'll have to answer somehow. It's very, very rare for that to give you an error in Python. Okay, questions or comments until here about this? You have questions about this? Could I have a second elif statement, something else? Yes, but. So I could say like, for example, here, let me just copy this and put it here. So I could say like elif first equal second, and then I could say like, and then I don't have to have an else at all. I could just do this. I would say it's usually a good idea to have an else. Even if, so what I sometimes do, like half jokingly, is to say like else print, right? This is mathematically impossible, right? It's good for a chuckle or two in class, which is all I get anyway, right? But it's good for a chuckle or two, but it basically means we know that we're never going to get here, but we want to make sure in case we ever do, something is terribly wrong and we should have the else there. So I'm a big fan of always having an else, even if it's super, super unlikely that it will, occur. Okay. Any other questions I can maybe answer about this? Let me show you something cool about this, or something terribly disturbing. You can choose. So I'm going to go back to my code here, and I'm now going to run it. I'm going to say, how about elephant and elephant? Notice the difference? One is a capital E, and it'll say here, oh, elephant, capital E, comes before elephant, lowercase e, alphabetically. Now, if you're human, And the odds are pretty good that you are. If you're watching this, you're like, wait a second. What is it thinking? And the answer is, of course, it's not thinking. Computers don't think. They have rules. So what's really happening behind the scenes? What's really happening is that Python is comparing the first letter and the first letter and says, which comes first? Well, how does it know which comes first? Well, way back when, you might have heard of something called ASCII. And way back when, all of the letters in like the Latin alphabet, as well as numbers and some symbols, were given numeric values. And that's how basically computers communicated for a long time. Because really, at the end of the day, computers are not sending letters, they're sending numbers, and those numbers are translated into letters. So everyone sort of agreed that ASCII was good until, what do you know, people discovered that not everyone in the world speaks English. Ha, shocker, right? Yeah, especially the Americans. And so basically what happened was they had to start incorporating other character sets. And that led to what we now call Unicode. And Unicode basically says, let's have all or just about all of the characters ever created by people in the same character set. So we can compare them. So we say, which comes first? Okay, but what does that have to do with this? Well, it turns out that you need to have separate letters and thus separate numbers, numeric codes for capital and lowercase. They're not considered the same. So if you ever check in Python, like capital Z is less than lowercase a. Why? Because all capital letters come before all lowercase letters. Now we'll see probably another 2 or 3 sessions how we can switch around our strings a little bit to be all lowercase. That's like the typical solution to this problem. We just force both to be lowercase, then we compare them, and then we can say they are or not the same. But Python is what we call case sensitive. And we saw this a little bit also with variable names, where if you call a variable a name on lowercase, which is traditional, that's fine. And then if you change it to use capital letters, then like Python won't have any idea what you're talking about. So case is important here. And here in this case, so to speak, you want to make sure that the comparisons are being done all in the same case. Okay, next up, ask the user to enter a single letter and indicate if the user has entered a vowel or not. Now we're going to see that there's some more clever, interesting ways to do this. But right now we've got some pretty primitive tools at our disposal. Yet we can still do this. So I'm going to say letter equals input, enter a letter. Now notice, we're asking the user to enter a string, and we are basically depending on the user's good graces to only enter one letter. If they enter more than that, their problem. Okay, this is where, like, the documentation will say the following the following functionality is unsupported or is undefined, right? And that's so that if you call into tech support, they'll be like, we're not going to help you with that. So now I want to check to see if it's a vowel. So one way I could do is I could say if letter equals a, right? Print a vowel, and I could say elif letter equal e, print a vowel. Elif letter equal I, print a vowel. You see where I'm going with this, and you're probably not very happy about it. Although, as I just said, like at least this works, right? And we can say here, else print not a vowel. Let's like make these comparisons. A, E, I, O, U, and this is here. Oh, okay. So if I run this now, and I say A, it's a vowel. And if I say I, it's a vowel. And if I say, and if I say T, not a vowel. And if I say like space, not a vowel. So it is accurate. But I think you'll agree with me that this is not looking so, I don't know, elegant. There is a real sort of general inclination to try and make things shorter, more compact, and just sort of more logical. So how can we do this given the tools that we have? What we could do is we can string different tests together. We can say if this is true, or this is true, or this is true, or this is true. And remember, the way it works is if true or false, or true or false, right? Then print one of them, at least one is true. That's basically how the or works, meaning whatever expression you have here needs to be true or false. Whatever expression you have here needs to be true or false, which means I can basically say, let's copy this a little bit. By the way, like, there we go. Let's just do A or that, or that, or that. And let's change the letters A, or E, or I, or O, or U. And then we'll say here, right, yes, it is a vowel. We can even say here, letter is a vowel. There's an F string there. And I can say here, else, print, I forgot that. There we go. Hey, what's going on here? Oh, I didn't close the string, that's why. And then now I can say print, no letter is not a vowel. So if I run this now, I say, oh, well, actually I need to get some input, eh? Minor issue. So I'm going to run this, enter a letter, A. A is a vowel. E is a vowel, and let's do, oops. Q is not a vowel. So this is working, and I hope you'll agree that this version is easier to understand than that version. And yet, and there was a little bit about this in the forum, it's so tempting to do this. If letter equals A, or E, or I, or O, or U. And so now if I say, hey, is A a vowel? Yes. Is U a vowel? Yes. Is Q a vowel? Yes. Is T a vowel? Yes. Uh-oh. Is space a vowel? Yes. All right. Clearly not working the way we expected. What's the problem here? The problem is that once again, what's happening is we're saying, is this true or false? And is this true or false? And when we turn to the letter E, we say, hey, are you true or false? And E says, hey, I'm a string. I'm neither true nor false. And Python says, you have to tell me, are you closer to true or closer to false? And Python's rules are that everything is closer to true, except for 0 and empty things. And because it's not the empty string, because it's not just quote, quote, this is considered true. And so basically what we've said is, if it's an A or true, meaning always. Now Ronnie asks, can I say the vowel variable like this? Can I say like vowels, right? That equals A, E, I, O, or U? And the answer is yes, but this is using a list, and that we will get to in a few weeks. You can also say like, vowels equals a string, A, I, O, U, and search inside of that. But we don't talk about really strings or searching so much, but that's definitely, but I would say this is probably the best way to do it, like what we call the most Pythonic way. But I just want to sort of use the tools that we have gotten so far. All right, so don't do this. I'm going to put like a big warning. No, don't do this. Really? Okay. Other questions about this? Okay. So let's talk about numbers. Oh yeah, you can search inside a string A, I, O, U. Absolutely, absolutely. So let's talk about numbers for a bit. So we've already played with numbers a little bit, right? I can say here, x equals 100. And what does it mean to be a number? So this is actually a special kind of number that you probably learned about back in like elementary school. Oh, why don't do this? Wait, when you say repeat it, you don't mean that, I assume. The reason that we don't want to do this is because every string in Python, let's say non-empty string in Python, is considered true in an if statement. So the below is like saying if letter equal A, or true, or true, or true, or true. And guess what? That's going to be true no matter what. All right, excellent. So when I say x is 100, what I'm really saying is x is an integer, right? A whole number. So I could say, hey, what's the type of x? Tell me, what type of data does x refer to? And it's going to be an integer. And ints are really, really common in Python because we use lots of numbers. We use numbers just for sort of displaying them and for counting things and for indexing things, although we haven't done that so far. Lots of integers. So if you've ever used another programming language before, you've probably heard about like how big is an integer? And the answer in Python is who cares? Certainly not that interesting to us. And why can I get away with that? Because integers in Python can be more or less infinitely large or infinitely small, right? We're equal opportunity here, both positive and negative. So basically, when you have, right, when you define an integer, it's creating an object in memory. And it's using as much memory as you tell it to. So if I say here x equals something really big, right? The type of x is still an integer. And if I say x equals x to the 20th power, Python is okay with that, right? And if I say, hey, what's x? It's going to be a really big number. Well, what if I say, no, x equals x to the 20th power again? Well, that's going to be an even bigger number. And we can do this all day, right? Scroll down with lots of zeros. So You will run out of memory before Python will complain about an integer being too big. The odds are pretty good you don't need to worry about that. But you just don't need to worry about integer sizes in Python. They're taken care of automatically by the system. And like, it's just not a concern. And if you're wondering why should that be a concern, it's because in many programming languages, they say an integer can be up to this many bits. And that many bits determines the maximum int you can have. And above that, the system will just say, sorry, integer's not allowed. Now, it's funny because Python is not a particularly math-centric language. And yet, integers are just sort of really flexible for us, and we can make them as big or as small as we want. So that's pretty great. We don't need to worry about it very much at all. And I think we saw before in the first lesson, if I say x equals 1 and y equals 2, I can say x plus y, right? I can just add them together. Pretty logical. But if I say x equals 1 and y equals a string 2, x plus y is going to give me an error. And that's because Python has a long-standing policy of not guessing. It's always like, if it's not explicit, if it's not clear, then Python's just going to throw up its hands and say, I don't know, I'm going to give you an error about this. So we need to be sure that we have two integers there. Yeah, but this leads to a problem. What if I say here, x equals input, enter, a number. And I say y equals input, enter another number. And I say here, print, let's do this, x plus y equals x plus y. So we use an f string here to take x and y and add them together. So I'm going to say here 10 and 3. And 10 and 3, as we all know, is 103. There we go. End of lesson for today. Wait, what? What's going on? Well, we've already seen that input gives us strings. It's giving us text. And can we add strings together? Absolutely we can. So x plus y, it's just treating them as text. Should the computer know? Should it understand? Maybe, but it doesn't. They just don't know these things. But this puts us in a bit of a pickle. Like, I very often want to get integers from the user. I want to get input that's an integer. Like, what am I supposed to do now? So it turns out, and this is generally true in Python, if you have data in X and you want it to, and you want, let's do this, and you want it to be of type Y, you can say Y of X, meaning you can run the type as a function on X. What the heck am I talking about? More specifically, X is a string and you want an integer based on it, run int of X. So if I say now X is like this, what if I do int of X? Again, this doesn't change X, but returns an integer based on X. And sure enough, now we get 10. And you can see X is a string, was a string, is a string there. You see the quotes. And here, X is an integer. Well, if X is an integer, now I can say int of X plus int of X, or int of Y even. And look at that, 13, because X is 10, or the string 10, and Y is the string 3. Again, what did I do? X is referring to a string value 10. Y is referring to a string value 3. When I call int of X, I get a new integer back. I call int of Y, I get a new integer back. I get 10, I get 3, we add them together, we get the integer 13. So this is a way for us to convert, or what people call casting, from one type to another. Specifically, I'm saying here, I want to get an integer back from whatever that string was. And it's really, really useful in this way. Now, I can do this to any string, assuming, of course, that the string only contains integer type digits. So if I say here x equals 1, 2, 3, 4, 5, and I say int of x, I get the integer 1, 2, 3, 4, 5. I say x equals hello out there. I say int of x. I'm going to get an error saying, wait a second, hello out there cannot be converted into a base 10 number. Now, why would this matter? Because I'm going to be getting input from the user, as we see here. I'm going to want to turn into an integer. I'm going to be getting input from files, and those come as strings too. I'm going to get input from the network, and that comes as strings also. In all these cases, having a string is great, but if I want to do mathematical calculations with it, I have to turn it into an integer. And this might raise the question, why does the computer need these different data types? And it's because each of them is handled in a different way. Each of them has different capabilities. Each of them, like in the case of integers, most of the functionality we use on ints is just handled by the chip in your computer, where strings have to be handled by Python. So it needs to know how to allocate memory. It needs to know how to, well, also return the memory to the system when it's no longer being used. It needs to know who is executing what type of functionality on it. And so having different data types is actually pretty important. So we can take strings, turn them into integers, and then print them out or do whatever we want with them. Okay, here's what I want you to do now. I'm going to give you an exercise. I'm going to give you like 3-4 minutes to work on it. It might not be enough time for everyone. That's okay. I'll go over it then. But like, I'm trying to keep this to an hour slot and still give you a chance to do some practice. So what I want you to do is ask like the user to enter a number. We'll call this X. And then we'll say, ask the user to enter a second number. We're going to call it Y. And then ask the user to enter an operation, either plus or it's called times. And then print either X plus Y or X times Y, depending on the, and we'll call this operation. Right, depending on operator. So the idea is basically that you're going to ask the user to enter a number, ask the user to enter a second number using the input function. And then you're going to say, hey, do you want to add these or do you want to multiply these? And the user will enter either plus or star. And then depending on what they give you, you'll either say print plus X plus Y or X times Y. All right, so I'm going to give you like 2-3 minutes to work on this. It is totally okay if you don't get to this. I just hope like the faster typers or some people will get a chance. And then I'll go over and I'll show you what to do. And then we'll talk a bit more about numbers as well. I'm just going to mute my mic for a few moments while you guys work on this. But if people have questions or comments meanwhile, please keep them coming. It would be great to see more stuff. But if I mute my mic, I'll just mute it here. I'm discovering the drawing things that you can do here while see, we call all their new stuff with the eraser. How does that work? Oh, it just erased the whole. Okay, fun stuff. Spotlight. All right, I'm not sure quite what that's doing for anyone. All right, let's go over this together before I cause too much more damage here. So let's ask the user enter number. So I'm going to say X equals input a number. We say here Y equals input, enter a number. Now, the fact is that input will always return a string. So whatever the user enters is going to be treated as text. We are going to have to turn it into a number. So let's say here, operation equals input into an operation. And then I can say if operation equals plus, then we're going to say print, and we can even like be fancy in F string. I'll say X plus Y equals, but I don't want to say X plus Y. I have to say int of X plus int of Y. And I can say here, elif operation equals star. Then I can just copy this basically. I'll show you another way to do this in a moment. And I can even say here, else print, right, operation not supported. So now if I say here 10 and 2 plus, 10 plus 2 is 12. Pretty cool. And if I say here 10, 2 times, 10 times 2 is 20. Happens to be accurate. That's pretty great. And if I say something else like 10 divided by 3, it'll say, oh, oops, now I'm really in trouble. That's gonna like, oops, let's do this. 10, 3 divided by, say divide is not supported. Okay, but wait a second, I mentioned there was another way to do this, at least one other way. And one way to do that is to say something like this. Say here, solution equals int of x plus int of y. Right, and here I could say solution equals int of x times int of y. And then I can just say sort of at the end here, well, I guess okay, let's just do this. I'm gonna ignore the, fine. Oh, you know what, we can do this. We can say here, solution equals no solution. Then I can say here something like print, right, x operation y equals solution. So I can say 10, 2 plus 10 plus 2 equals 12. And you see what I did here? Basically, I created a new variable, and then I use that variable later on. Do you need to do this? No, but this is like, oh, raise your hand. Brian, just go ahead and you can ask in the chat. Oh, sorry. Try to switch it to the, oh. You can ask in the chat if you have a question about things. Don't be shy, don't be shy. So basically, we're already starting to see like some complexity here in terms of, wow, I can get some input, I can do an operation. And you can see then I could, of course, extend this to have additional operations, you know, minus, times, divide, whatever I want, based on, you know, whatever sort of interesting to me here. So all this is possible, definitely all this is possible. Questions or comments about any of this so far? Okay. So let's go a little deeper into numbers. By the way, like Python is happy to deal with, like, again, it'll turn any string that it can into a number. You can also, here, let's watch this. If I say here, x equals input, enter a number. And then I can just say x equals int of x. Oh, here we go. Byron says, is there a way of turning the operation input into an operation without using if? Can the program recognize star star? Meaning what? I'm not quite sure what we mean there. What would you like to do? Like, you want to like actually? Oh, I think I understand. Oh, I think I understand. Okay, so the answer, right? So the answer is sort of. You can actually take a string, or you can create a string. You can hand the string to a function called eval, and eval or exec is probably more appropriate here. They're eval and exec, they're slightly different from one another. And those are functions in Python that take strings and they execute them like tiny little Python programs. So I could say, for example, like exec, print, let's say here, 2 plus 2. Actually, no, I guess it would be like, 2 plus 2, something like that. And it would print 4, because like the string here is the program. But exec is like really, really, really black magic, and you can get yourself in a lot of trouble using it. Because think of what's happening here. If you're asking the user to enter something, and then like you execute it as a program, you are asking for also security issues. So so don't do that. And I often say that there's like, so there's exec and there's eval, and I often say that there's a 75% overlap between eval and evil, because it can really be used in all sorts of terrible, terrible ways. So I was like, what if someone enters a float number that would happen? Excellent question. So let's try it. If I say int on 1, 2, 3, 4, 5, 6, floating point number means something with a decimal point in there. And actually, it's fine with that. But if I say int of the string 1, 2, 3, 4, 5, 6, bad news. Basically, the int function is very, very strict. It will only accept a string that contains digits in it 0 through 9. None of this decimal point stuff. It will forgive you if you have spaces on either side. So if you say, for example, int of 1, that's totally fine. It'll get rid of the white space. But everything else, it's kind of strict about. And I understand they don't want to like mess things up too much. What was I going to say? Oh, so let's just see like a different way to do this as well. What I could do is I could say, I think I showed this, x equals input of, enter a number. And I can say x equals int of x. And so this drives people crazy if they come from a language like Java or C# or C or C++. Because in those languages, this is like expressly forbidden by the language. Because if here x is a string, you can't say, oh, and now x is an int. Right? You can't have the same variable refer to different types of data. And yet Python is totally happy to do this because it's what's known as a dynamic language, meaning variables don't have types. The values they're referring to have types. And so what you start to do here as like a very natural thing, people in other languages think it's like crazy talk. Now, it is true that you can end up with some weird bugs as a result of this. And so there's been a growing interest in the Python world in actually tightening things up a little bit, not changing the core language, but there's something known as MyPy that lets you sort of check to make sure you're not doing this sort of thing. But if you're pretty confident that your user is going to enter something right, or if you're just doing something for yourself, then this will work totally fine. And of course, then if I say, print x times 100. So now if I say like, 1, 2, 3, 4, 5. So that works just fine, because what happened? We got x as a string from input. And then again, it's always right side before left side in assignment. So here we're getting the integer value from x, converting integer value from x, and then assigning it back to x, because just doing this doesn't affect x at all. This just returns a new integer value that we can use, and then we're going to assign it to the x variable. And so we can do that for sure. It's generally a good idea to like double check and make sure the users are entering the right thing. But at this level of what we're doing, I don't think it really matters that much. I think it's more important to sort of assume our users are actually nice people. Haha, silly thought, right? And basically we can then sort of work with their inputs. Okay. Other questions about this, and then maybe we'll talk for a few minutes about floats as well, which will be fun. Okay. And if you have questions, you can just keep them copy. That's fine. So we've seen so far that like if I say x equals 100, the type of x is an int, and any positive or negative whole number is an integer in Python, just is by definition. But what if I say x equals 100.0? Right? Adding a decimal point means it's a float. What is a float? A float is actually, well, we know what it is from like, elementary school math. It's a non-whole number. It's a number with a fractional part. In this case, the fractional part is 0. And if I say, what's the type of x now? Sure enough, it's a float. So there are actually two different types of numbers in Python. And this is true for many, many, many programming languages. And that reflects, again, that at the chip level in the hardware, that your chip can handle integer math and your chip can handle floating point math. Now, do you really need to care that much? The answer is, as always, yes and no. On the one hand, it's just kind of convenient, right? I can say like 10.5 plus 20.5, and I'll get a number there, and it all works out pretty well. At the same time, floating point math is a bit slower than integer math. Not that you're ever going to feel it or notice it, but you should know that it is the case. The other thing is floats are not as accurate as you might think. Here's one of my favorite demos to show people. 0.1 plus 0.2. What is the answer to this problem? I'll let you all think for a moment. All right. I'm sure you got that answer, right? If not, you should really go back and demand your money back from your elementary or middle school. What the heck is going on here? What is going on? Well, it turns out, remember, that at the end of the day, all math in Python and in all computers, just about all computers, it's handled at the chip level. And that is binary math. That's to say, using just ones and zeros. And we're using decimal math. And that sort of, the gateway between decimal and binary and then back to decimal reveals some flaws in this. And one of the flaws is that, if I say like 1/3, 1/3 is not writable as a terminating decimal. Right? It can go on forever and ever and ever. And that's just because you can't evenly divide 10 by 3. Well, guess what? You can't evenly divide 2 by all sorts of things also. And so there are all sorts of numbers, floating point numbers, that in decimal work just fine, but in binary are non-terminating fractions. And this is one of those. And by the way, here's another cool demo. If I take this number and I copy it, I put it into my browser and I add a .com, I will get to what? Oh, I guess hold on, so let's just do this. It's more dramatic usually. There we go. I get to a site actually called this, where it shows your language isn't broken, it's doing floating point math. And it shows tons and tons and tons of programming languages and how they all have this same flaw. So is it really a bug if everyone does it? Well, the answer is of course yes and no. It's known, documented behavior. It's something that we know that floats do. And so you can't, you just have to sort of live with it. So what if you're a bank and you're doing all sorts of calculations with people's money? Do you use floats? Maybe. I used to think the answer was no, absolutely not. It turns out the answer is yes, assuming that the bank actually knows what's going on and then can deal with it accordingly. So like banks will use floats, but they know where the limitations are and they'll stay clear of those. Other banks and other places that deal with money and sensitive stuff will use other forms of numbers that maybe take longer and take more memory, but are also more accurate. It all depends on how much accuracy you actually need. So floats, very useful, wonderful stuff, different from integers. But at the same time, we know that 1 plus the string 2 won't work. But 1 plus the 2.5 will work. So this whole I won't work. Oh, the bank limits to 4 digits. There we go. So if I try to add an integer in a string, Python says, no way, I don't know how to do that. But here, if I use integer plus float, if I use integer plus float, then Python's like, oh, that's okay. I know how to deal with this. And the answer will always be a floating point number. So if I say 1 plus 2.5 or 1 minus 3.8, right? So all that is totally fine. You just need to worry about it when you're dealing with division or when you're dealing with very small quantities there. All right, so we've got integers and we've got floating point numbers, and both exist and both are used all the time. By the way, let's say I have a string, so s equals 123.456, and I want to turn this into a float. So to get a float, use float as a function. We can say float of s, and we get back a floating point number. What if I say int a float of s? Well, let's see. We're going to take s, the string, and get a float based on it. So far, so good. Then I'm going to apply int to it. So it's going to take the float and turn to an int. It's going to chop off the decimal point there, and that works great. What if I say float of int of s? Well, that's not going to work, because int of s is going to choke on the fact that we have .456. But what if I say float of int of 123? So int is going to take, let me turn this to a string. That'll actually make it more interesting. Int of string 123 is going to return an integer, and then I'm going to turn that into a float, which is useless, but will work, and then I have 123.0. So whenever you see the 0.0, you know that you're dealing with a float. And there are here and there things that you can't do with floats. By the way, floats do have a limit. I don't remember exactly what the limit is, but you can't just go like infinitely large or infinitely small. I forget exactly what the number is. I'll have to look it up somewhere. But basically, if you try adding to the maximum float, adding 1, you will actually get the same float back. It's kind of wild, because Python's like, well, you're sort of at the end of the universe, so you can't go any further. So we've seen then that you can get input from the user, turn to a float, turn to an integer, turn to a float, and then you can do all sorts of stuff with it. So let's try something now with a floats, just like a simple sort of thing. In fact, let's do the same exercise as before. Ask for 2 numbers, and ask for an operation, but use floats instead of ints this time. The result. All right, so I'll give you like 2 minutes. Oh, why do you get an error from int float of int? Sorry. So the answer is just that our string there, where did I put it? Oh, here we go. So the string was 123.456, and int choked on that. The problem was not getting a float from an int. The problem was that int was giving us an error first, because there's ways to say decimal point, I don't know what to do there. So that's the issue. But once we do it, if we do it like float on int of 123, where there is no decimal point, that is totally fine. All right, so try doing the same thing as before with floats instead of ints, and we'll go over in like 2 minutes or so. And I'll show you 2 or 3 other sort of cool, fun things about numbers in Python, and then I think we'll come close to finishing up for today. All right, so I'll just mute my mic again, and then if you have more questions, please put them in the chat. I would love to see what people have to say. There we go. Okay. Sorry. There we go. Now I'm not muted. Still muted. There we go. That was a lot of messages. Thank you. I guess people are paying attention more than I am. Sorry. Well, you just missed the most important part of the whole course, so you're lost. All right. Well, here I'm just going to basically do it the same thing. As you can see, it's basically the same code, and that's because once we turn it into a float or into an int, it doesn't really matter. Plus is going to work exactly the same way, and that's part of the beauty of a dynamic language, or just programming languages in general. They're designed this way that once you understand how to do it in one way, you can use it the same way, same thing for different data types. And so here I'm just going to say, oops, that operator, and I can say here print. We can say here, x operation y equals, and then we'll say here solution. So if I say now 10 and 3, watch this, plus, look what I'm going to get. See, because it turned it into floats. So now we see 0.0, 0.0, 0.0, even though I just gave it an integer, or what looks like an integer. If I say 1, 2, 3, 4, 5, 6, and I say 3 times, it's going to give me, there we go, it looks pretty good to me. So basically, we can turn strings into floats. It's a really, really common thing to want to do. I'll also add that F strings avoid all the pain of doing the opposite, especially when I print it out, because the F string is automatically turning our integer and our float back into a string. So we can have lots of integers, lots of floats, do all sorts of things with them. Right now, we still have sort of limited tools for working with them, but these are like really, really, really fundamental, important things. I want to show you two sort of cool, nerdy-ish things that have to do with numbers in Python. And then if there are no more questions and no more accidental mutings, then I think we'll close up for today. First of all, let's say I have a number here. So s equals 100, right? And I want to convert it to an integer. So I say int of s. Great, it's 100. And I show this to my boss. And my boss is like, no. You didn't read the specifications very carefully. This is not 100 as a decimal number, right? This is a hexadecimal number. What the heck is hexadecimal? So it turns out, remember, that computers use binary numbers, which is base 2. And then so programmers then used a lot of octal numbers, which are base 8. And then programmers also used hexadecimal numbers, which are base 16. So let's talk through this. Base 2 binary numbers, fine. I can actually type them into Python. I can say 0b 101010. And 0b means, hey, right, this is a binary number. Interpret it as such. And we see then we get back 42. So it is an integer in every possible way. There's no difference between saying 0b 101010 and saying just 42. It's just an alternative way to enter an integer here. But what if I have, well, okay, so binary numbers, fine. We sort of understand them, and here and there people still need them. I mean, people need them, but typically not in high-level languages. Because binary numbers are kind of annoying to deal with, because you have all these ones and zeros, many programmers for many years used octal numbers. And those we can represent with 0, O. And I beg you to use a lowercase o and not a capital O. And 1, 2, 3, 4, right? This is an octal number. Right? And so what does this mean? This means that the digits here are not base 10, but they're rather base 8. Now, who came up with this crazy base 8 thing? And it turns out that base 8 is like an easier way of dealing with base 2, because it's still sort of closer to it. It's within the same, like, I can't describe it better than that. I'm sure I can if I really thought about it. Basically, I guess each base 8 digit is what, like 2 digits, 4 digits, something like that, in binary. And so a lot of older programming languages especially used to use a lot of octal. And then people said, well, if octal is good, base 8, then we can also use hexadecimal. Now, hexadecimal numbers, base 16, that's where things get really weird, because you can sort of understand base 2, right, zeros and ones. Sort of understand base 8, where it's 0 through 7. So you count in base 8, 0, 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, right? So actually, if I say 0, O for octal, 10, that's how we say 8. So 8 decimal is 10 octal. Oh, and in fact, here's like a nerdy joke alert. All right, so why many programmers confuse Halloween and Christmas? Because oct 32, or sorry, oct, wait, 31 is the same as decimal 25. And indeed, 0, O of 31, 25. Thank you, thank you. All right, you can show this off to your friends and tell them that you're indeed taking a nerdy programming course. So basically, hexadecimal numbers they go from 0 through 9, and then A through F. So as people like to say, it's just like counting normally, except if you had 16 fingers. So you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 10, 11, 12, 13, 14, 15, and so on and so forth. So many people used to use hexadecimal. If you've ever done CSS for colors on the web, then that uses hexadecimal. It's like 0 through FF, 0 through FF, 0 through FF, and FF, near XFF, is actually 255. Why am I telling you this? Because if you ever have to deal with different number bases, you can use the 0b or the 0o or the 0x. You can also just say int of FF, comma 16. Notice an optional second argument to int indicates the number base. And so if you get a string from the user and you want to say, oh, wait, interpret this not as a regular decimal integer, but rather a hexadecimal integer, yeah, Python will do that for you. Now, how often nowadays do I actually use binary, octal, or hexadecimal? Almost never. Here and there I need it, but it's not that common. That said, I once taught a class at a company and I said, and no one ever uses this anymore. And literally the entire room said, we do this every day. So there are still people who are doing this, just less common in my sort of neck of the woods. So that's like, just so you understand that Python allows us to work with different number bases, although at the end of the day, an integer is an integer. There's no such thing as a decimal integer or hexadecimal integer or an octal integer. It's just different representations of the same thing. Last nerdy thing to show you. So Python actually has 3 types of numbers. Talk about 2 of them. We have integers, and we have floats, and we also have complex numbers. Now, if you've ever heard of, so complex numbers, just so you understand, so complex numbers have a real part and an imaginary part. I kid you not, right? And the imaginary part is multiplied by I, which is the square root of -1, right? So the imaginary part is times I, which is the square root of -1, which is, of course, imaginary because you can't get the square root of a negative number. This turns out to actually have incredibly big mathematical implications. How big? So big that I did not do so well in those courses in college. But I promise you that complex numbers are actually important. And so if you want to, you can say here, 10 plus 5j. Let's do x equals this, and y equals 3 minus 7j. And you might be saying, wait a second, you said I. Oh yeah, but engineers use j, not I, so that's what Python does too. And so if I have x and y here, what's the type of x? Complex. What's the type of y? Complex. And I can say x plus y, or x times y, all sorts of wild and crazy stuff. Now, this is, again, something I have literally never used since I graduated from college. And even in college, I didn't use it as much as I should have, it turns out. But just so you know that Python really can handle all sorts of complex, literally mathematical stuff in addition to the basic stuff. Questions, comments, thoughts about any of this? All right, I'll wait a few moments for people to write in the chat. Meanwhile, I'm going to say, if working with numbers in Python seems easy, that's because it is. It's very common, very easy, very fast. There's not a lot to say about it other than, hey, we have these numbers, we can do stuff with them. Oh, I will show you one more thing that was actually kind of important. So I can say here, x equals 5, let's say. Let's say I want to add 1. So I can say x equals x plus 1. And this means add 1 to x, and then assign the result to x. Right? And remember, equal sign is assignment. It's not comparing. So first on the right side, we're going to add 1 to x. That's going to be 6. Then we assign it back to x. And so now the value of x is 6. So we can increment x by 1 with x plus equal 1. Right? This means the same as x equals x plus 1. And now if I've done this, now x is 7. So this is super, super standard in Python for incrementing integers. I assume you can do it with floats, actually. I never even tried. X equals 1.01, x plus equal 1. Yeah, that worked just fine. Okay, sure. So basically, if you ever see someone with plus equal, minus equal, times equal, divided equal, heaven help us if they do exponent equal or modulus equal, but all those will work. This is what it means. It's just like you just expand it out to be x equals x plus 1. It's a sign that's replacing the value. You should also know that in many other languages, you have something called plus plus, which does something similar. Plus plus does not exist in Python. If you say here x plus plus, Python will just laugh at you or cry with you, whichever you prefer. All right. So if numbers seem easy, as I said, that is good. I will put in the forum, probably tomorrow night, probably Saturday night, early Sunday morning, I will put 2 or 3 questions for you to play with, work with, puzzle over. If you have more questions, problems with installation, whatever it would be, let us know in the forum. I'll try to help you. Maybe others can help you as well. If you have friends who might be interested in this course, it is never too late to join. All of the videos are available. So I'd love to have more people join as well. Oh, here we go. For nested if statements, is there a quicker way of doing Java and Pascal? Oh, fantastic last question. So Baron asks, what about like a case or switch statement? Instead of like doing if or elif or elif or elif, maybe we can have like what a case switch. And the answer is no, Python does not have that. Python has a strong ethic of there should be only one way to do anything. And so that cuts away at a lot of the extra stuff that other languages have. Some people really miss it. I actually don't miss it very much. So that's what I sometimes do to people is say, if you're looking for the switch statement, switch case statement from other languages, in Python, you can use if instead. It's shorter and easier to spell and saves memory. And that's about the level of humor that my students always get. So you're the lucky ones. All right, any other last questions? All right, folks. Thanks again for a wonderful week. We'll be back next week, and we're going to talk about strings. We're going to talk about text, how we can not only get input, which we've done already, but we can transform it a bit. And that will lead us into, probably we'll do 2 weeks on strings, basic stuff, and then we'll start dealing with for loops and iteration. And that's when things are going to get complex and wild and crazy. Have a great weekend, everyone. I'll see you in the forum, and look forward to seeing you next week. Okay. Let's go a little bit. Bye, folks.